Good morning, 8th graders. I wanted to talk to you today about our CFA that we took last week. I do want to remind you that for today, after you watch this video, remember you're watching this video if you can't join our whole class Google Meet today. If you can join our Google Meet, you can stop watching this video. But remember today we are doing the 1.3 CFA on Kami, so you know you're at the right place if your screen looks like this. I'm reviewing the last CFA, so note that your CFA should look different. The problems will be different. But for today, do the CFA, and then we are reviewing the number names. We have a test coming up on Thursday this week, and I know that a lot of students could benefit from reviewing that. So please take a look at the PowerPoint I attached to today's must-dos. Look that over, study it, and then practice the Quizlet and do as many problems as IXL will let you. Those are the must-dos for today. I do want to review our CFA from last week. I want to review some common errors students made. Overall, it was pretty good, but let's use a text box here. I'm going to go in random order. I might not go in order, but just follow with me. For 3, when you see the cube root, which is a 3 right here, that means we need to find a number multiplied by itself 3 times that would equal -8. Notice a cube root is different from a square root. A square root won't have that 3 inside of the radical. Here, a cube root, some students showed me that they knew 2 times 2 times 2 was 8, and they were right. 2 times 2 is 4, and 4 times 2 is 8, and they wrote that as well, which is a great way of showing work. But we needed to find -8. So here, I would want to see you write -2 times -2 times -2, and I needed to see this work for you to get full credit. Here, we know -2 times -2 is a +4, and 4 times a -2 is how we got that -8. Okay, so for this problem, number 3, our answer was -2. Okay. For number 2, I want to show you that the square root of 49 is perfect. We love that square root, and lots of students knew that 7 times 7 would equal 49. And then we have to acknowledge this negative sign. I did tell students that if there's a negative under the radical, then that number would be imaginary. And I saw some students write that, which I liked your thinking, but we needed the negative sign out front. Okay, if the negative sign is out front, that is perfectly fine. We just take the square root of 49 times that negative, and that is how we got our final answer of -7. And I'll write that up here. -7. Okay. I'm going to jump down to 5, and I also want to talk about grading. So numbers 2 and 3 were learning target 7. And numbers, let me see if I can write this. So learning target 7 was 2 and 3. Questions 2 and 3. And for learning target 7, you can earn up to 4 points. I'll put it right there. If you just put like a 7 here, say you got 3 out of the 4 points for 2. And then say here you might have done -8 times -8 times -8. You knew you had to multiply a number 3 times, but you used a -8. Remember, this was incorrect, but you kind of had the idea of what to do. So here, say you earned 2 points. Since learning target 7 assessed number 2 and 3, You earned a 3 for number 2 and a 2 for number 3. Then I would average those and you would get the lesser score. You would earn 2 points for learning target 7. Okay. Say for number 5 and 6 you earned 4 points and 4 points. You would get 4 points for learning target 8 since learning target 8 was for questions 5 and 6. And say you got like a 1 out of 4 for number 1, and say you got 3 out of 4 for number 4. I would average those, and in the middle is 2. So I would give you 2 points for learning target 5, which was over 1 and 4. Okay. This is kind of how grading goes, and I can try to write, like, if you got a 3 and a 2 for learning target 7, you would get the lesser score. But if you got like a 2 and a 4 for 5 and 6, then you could get a 3 since that's the score in the middle. Okay? If you have questions about grading, you can email me. But let's review number 5. I want to remind you that I wanted to see you take the square root, and I'm going to try to draw it very badly. I wanted to see you take the square root of each side here. This is s squared, and the opposite of s squared is taking the square root. When we do that, we get s by itself equals 16. But that 16 still has that square root. Remember, the exponent of 2 and the square root undo each other, but this is still the square root of 16. And let's remind ourselves that we're trying to find a number multiplied by itself 2 times that would equal 16. And lots of students got this right. They knew that s equaled 4. And they knew that because 4 times 4 equaled 16. But when we have a square root like this in an equation, we can remember that there are 2 answers. The second answer is -4. And we know that because -4 times -4 equals a positive 16. A negative times negative is still a positive. So here I would circle my 2 correct answers of s equals 4 and s equals -4. Okay, if you just gave me s equals 4 and you showed all of your work, you could have earned up to 3 points. But if you just gave me s equals 4 and no work, then you would not have earned that many points. I want to show you that for a cube root, we are still doing the same idea, but I'm not taking a square root. I'm going to write this 3 in here to show that I'm taking the cube root to undo the cubing. And when I do that, I get x equals the cube root of 125. And I need to see this cube here as well. From here, remember, a cube root from number 3 means you need to find a number multiplied by itself 3 times that would equal the number under the radical. And here we have 125. You could have guessed and checked. I know this is a positive number, so my answer will be positive when it's a cube root. And 5 times 5 times 5 would get you the right answer. Notice 5 times 5 is 25 times 5. And you could write that off to the side or show me that that was 125. So here, I do want to see you write x equals 5 for your final answer. I don't want you just circling 5. Remember, for a cube root, you only have one correct answer. Okay? For 1 and 4, I want to remind you that these are imperfect squares. We do not like them because they aren't perfect. But we can use what we know to estimate them. I'm going to show you how I would estimate one of them, and then I'll show you just the answers I would have accepted for the other. For number 1, the square roots I would want to see you identify are let me change my color. The square root of 36, which equaled 6. Remember, we're using what we know. We know our perfect squares. Please mind my messy writing. And then we also know the square root of 49, which is 7. And we have the square root of 43. And when I think about this, I'm thinking the square root of 43 is 7 away from 36, and 43 is only 6 away from 49. So that tells me the square root of 43 is going to be a little closer to 49, but it's almost exactly halfway between the two numbers. Okay, remember it was 7 away from 36 and 6 away from 49. Because of this, I would have accepted the estimate of 6.5. Remember, my estimate needs to be between 6 and 7. So I would have accepted the estimate of 6.5. If you also notice that it was a little bit closer to 49, I would have also accepted the estimate of 6.6. Okay, anything other than that, I would not accept. We know that it is closer to the square root of 49, so I would not accept 6.4 because it is farther away from 6 since it's 7 away from 36. You only needed to write one estimate, but these were the ones I would have accepted. Okay, and I can walk through this one with you. For number 4, our perfect squares were 81, which equal 9, and 100. And here we can tell 83 is much closer to 81 than it is 100, which tells you that your estimate will be much closer to 9 than it will be to 10. Square root of 83 here. Notice 83 is only 2 away from 81, but it is 17 away from 100. Because of this, I would accept the estimates. Remember, those squiggly lines show it's an estimate, an approximation. I would accept the approximation of 9.1 or 9.2. Remember, you do not need to write both estimates. Either or is fine. Okay. Thank you for watching. If you had questions specifically about your CFA, you can email me. Otherwise, go ahead and get started on today's work, and I will see you tomorrow.